So on the bottom of your cover, the front of the lab book, try and balance these three equations just in that open space right there at the bottom. They all work. So if you look up there and think, well, it doesn't work. Nope, they work. I would say the top one is the hardest one, yes. All right, I'm going to pause this again. Oh, maybe I'm not. Here we go. So number one's the trickier one because sometimes you think HOH has two H's, but it has one H and one OH, if you remember from yesterday. So the only subscript I have to fix is here. So if there's two there with this hydrogen, I'm going to put a 2 right here. And that applies to this hydrogen. Now, it also means there's how many OHs? 2. So in order to fix that problem, I need to put a 2 in front of LiOH. And that takes care of the OH, but now I just made 2 LIs. So over here, I need a 2. And then I'm back to where I started. So I put a 1. 2, 2, 2, 1. How many had that right? Okay, not bad, not bad. Okay, this one, the way the test works, and it's a ways away. Don't worry about it. The way the test works is like the last test when we did the naming. In balancing, there are 3 that are easy. There are 2 that are medium, and there's 1 that is hard. And you have to get 4 out of 6 to pass it. Okay, so you only need to get 1 of the medium or 1 of the hard. This one is considered a medium. Both of these would be considered easy. All right. Now, next. Hi, Blake. It's good to see you. I've missed you. You did? Oh, that's sweet. I don't know. Has your name on it. That's all I know. Okay. This one we have a 2 with the CL, a 2 with the BR. So you can fix either one of them. So if I have 2 CLs, I need to put a 2 in front of where the CL is. That takes care of CL, but now I have 2 NAs. So I have to come over here and put 2 with the NAs. That takes care of NA, but now I have 2 BR. And that's perfect because I have 2 BR. So then I just put a 1 and then a 1 where I started. Who had that one right? Raise your hand. Okay, good. And then the bottom one, this one I see a 3 and 2. That means I should do the swap-a-roo. So if there's 3 oxygens on one and 2 on the other side, I put the 3 in front of the 2 and this 2 in front of the 3. That takes care of those. But now there are 2 of 2 irons. So then that would make 4. Okay, how did we do? Who had that one right? Okay, who went 3 for 3? It's more than just Ethan. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, that's pretty good. We will do more and more of these as we go. I said something wrong, by the way. I said the pictures were taken here. There are some pictures taken here, but they're taken here. Whatever. You can walk around here and you can walk around right up here. It's pretty cool. Okay, moving on. You wanted to do chemistry, right? Oh, hey, look at that. Number 1's already done. Let me move this. Oh, hey. Ooh, you didn't even see that, right? Okay, page 4, my friends, page 4. Modeling, so visual. This is like what we did yesterday with that first one where you wrote it out, you balanced it, and then you drew it. So if we look, we will do these 4 things. I'm not going to make you build the models, but I'm going to make you draw them and color them with colored pencils here in a second. So the instructions, number 1, translate the chemical reactions below into chemical formulas. So right here, Aluminum is Al. Oxygen is O, but there's a 2. Who said that? Nice job. How'd you know there was a 2? Because it's diatomic. Everyone take your periodic tables out real quick if you have them. The one from first trimester that we colored, not the, like, there you go. Now, I know it's the same piece of paper, but I want you to look at the side we colored first try. All right. If you look at oxygen on the far right side, it's like right here. Months and months ago, we wrote a number for this very moment. We put a 2 right next to oxygen, right? And then right up here, we put a 2, and that meant it was diatomic. When you have a word and I ask you to find the formula, if it's a single element, you need to double check to see if it is diatomic. So aluminum right here, did it have a 2 next to it? Nope, so it's just Al. Oxygen, it had a 2, so it's Al, then it's O2. Okay, now we have aluminum oxide. Now, my good friends who I love, appreciate, and I'm excited to be back, most of you will do this wrong. You will go AlO2 and you move on with your lives. But this is super wrong. This is not the formula of aluminum oxide. Aluminum oxide, we would use our naming schemata to determine that it is the symbol of the metal and then the non-metal, and then we have to drop and swap. Al is in family 3. Oxygen is in family 6. Al2O3 is the correct formula of aluminum oxide. So let me rewrite this cleaner. Al plus O2 goes to Al2O3. All right. Then tell your partners, answer this question. Is this already balanced? No, it's definitely not, right? So then that means we need to add coefficients to balance it. Will you take a minute and balance that on your own?
Why would oxygen have 2?
Whoa, whoa, who just talked to me?
Sorry, it's me, Curtis.
Curtis, hello. Why is oxygen a 2 right here?
Yeah, if it's just a single element.
It is a single element. Do you still have your periodic table with you?
Yeah.
All right. Do you have the one from first try that you colored?
Yeah, I do.
All right. Look at oxygen, and you should notice a little 2 next to it because oxygen is diatomic. What?
My bad.
Curtis Larson. All right. What diatomic means, everybody, is oxygen, if you remember from the dots a long time ago, it only had 6 dots, but it wants 8. So oxygen is pretty aggressive, and 2 of them will bond together and share. So this is written as O2, or we say it's diatomic. There's only a few of them that are diatomic. They are H, N, O, F, Cl, Br, and I. Those are your diatomics. They're listed on your naming schemata, and we've put a 2 next to them on your periodic table. All right, then let's jump in here. So did we already balance it? What do you do if you see a 3 and a 2? You do the swaparoo. The 3 goes in front of the 2. The 2 goes in front of the 3. And then what do we put in front of AL? A 4. Okay, then we're going to draw it out. And I already did. You have 4 ALs. They are not connected at all. The subscript, sorry, the coefficient tells me how many things there are, but it doesn't tell me like how they're put together. It just says 4 AL. What? No. Like it seems to make sense, like to reduce them, that's right. But if I cut them, I have to cut all of them in half. And so then we'd end up with 1.5 O2s, but these have to be whole numbers. So that is actually a really good question. It's just we can't have fractions. All right, so 4 ALs plus 3 O2s. Tell your partner, if you don't remember, what will 3 O2s sort of look like?
3 O2s.
No. Are any of them going to be together? Yes is the answer. You'll have O2s, and how many pairs of them? 3. Whew, that's something I don't know. Okay. Then we have 2 Al2O3s, so that's 2 things that are pretty complex, and that's what they look like. You are a shining example of what students should be like. What, Blake? You are an example of a kid that doesn't like school, but will probably eventually be rich. Because you're going to probably start some sort of welding fabrication company, and you'll be driving a F-350 that's jacked up with mud flap violations, and you're probably going to roll your coal in my window every day on driver's ed, and I'll think that kid sucked in class, but now he makes 180 grand a year pulling your boat to Willard Bay with a cooler full of who knows what, all your ladies. There you go. So he would not have a cooler. Uh-oh. Are you a Dodge guy? Chev? I didn't mean to insult you. Okay. Okay, that crossed the line. Some people in here probably do like guys. This is all recorded. Oh no, let's move on. Okay, now what you're going to do, you're going to color these as well. So what I need from you, I'll put the pencils out. I need a balanced equation. I need a picture that is colored. Remember from yesterday, there's a reason I have you do this. I want you to see the equality. There are 6 blues on the left, 6 blues on the right. They're arranged different, but there's equal numbers of them. All right, and then 4 and 4. And I'll get them, Kennedy. I can sense that you're super excited to color. Now, you don't have to have that color combination. You just need whatever you choose, make them the same. I think you need 4 or 5, probably more. You need 6 total colors. Just grab a handful.
Grab some and then I'll figure out when I get there. How many did you say we needed?
Not that many.
Well, I just grabbed some so I don't have to wait. And then you said 5?
Yeah.
5? That's a nice looking color. This one's never looked better. I'll just take your extra here. And to be honest, I'm digging the gray. All right. You guys can take from that. Cheers. Wait, how many colors do we need? Just 3.
What?
How many colors do we need?
6.
6? Oh, I need 6. Green, orange, Whoa, I know you like pink, but sorry, man. I already got the orange. Got a sharpen. Oh, I got a sharpen. What kind of pink is that? Pink or purple?
Yeah, it's in an open drawer right next to the iPad cart.
What kind of purple?
It makes a mess, so I hide it in there.
I love it. Varsity basketball. Oh, let's go! Dude, get me on that team, baby!
I'm glad that was sort of quiet. Is it stuck, James?
Yeah.
That's not good.
You get like another sharpener.
Okay, I think it'll work. Try it now. Yep. Yo, you're coloring the circles. Like,
Wyatt, you're a smart guy.
so put a little color over AL, little color over AL. I'm going to turn one of the lights on. Uh-oh, oh, it's right there. Whew, that was close. I miss Cohen. And Curtis. Curtis, I miss you too.
Thanks, man.
You're welcome. Does someone have COVID at your house?
No, it's getting served.
I'm quarantined for surgery.
Okay, that's good to hear. It'd be rough to through your house with 1 million people.
Yeah, you're right.
All right, let's look at the next one. I'll do the next one with you, and then I'm going to tell you to do the rest on your own. So calcium chlorate. You may need your naming schemata. Whew. Oh boy. Calcium chlorate. I will help you. Is this the name of a single element? No. Are there metals and nonmetals? Is that the next question?
Probably so.
Sure. There is. Yada, yada, yada. Does it end with ATE?
Yeah.
Yes. So we went down, we went down, we went down, we went over. We should be here. Says, write the symbol for the metal first. Ca is calcium. And then the polyatomic ion. Oh boy, where do we find polyatomic ions?
You find it on the thing.
On the naming schemata. So can someone tell me the formula of chlorate?
Spencer, go. I don't know. I haven't
The
found
formula of chlorate. Amber, you got it? Bottom left? ClO3. What's its charge?
it.
-1. All right, so then we have to drop and swap this thing. The charge of calcium is +2. So it's CaClO3 2. What's up, Blake? All right, so that's calcium chlorate. Now, calcium chloride is different. Does it end with ATE? This one. No, so this one we just go straight down and we end up in the box right here on your naming schemata that says, put the symbol of the metal first and then put the non-metal. Chloride is chlorine, which is Cl. Then we got to drop and swap. Calcium's a +2, chlorine's a -1, so CaCl2 plus oxygen, but it's diatomic.
So it has a 2.
Fantastic job, Odessa. Appreciate you coming through clutch right there. Okay, now we would then, now that we have all this part written, we would then have to balance the equation. So I look here, the polyatomic ion breaks up, so I have to treat it on its own. I have 6 oxygens, I have 2 chlorines, so make sure we're ready to go. So if I have 6 oxygens here, what number do I need right here? A 3. Good work. All right, then if I have 2 chlorines, I need 2 chlorines, which I have. So that's a 1 and a 1. Okay, so the balanced equation is 1 CaClO3 2 goes to 1 CaCl2 plus 3 O2. All right, drawing this one can be a little tricky, so I will definitely help you. Whoops, that button. Here we go. This one I really like, and hopefully it helps this whole process to make sense. We're going to draw one thing, but it's all of this crap. Now, please look at the screen and ignore Blake. The one thing we're going to draw is connected to 2 things. So I have calcium, which I'm going to draw, and it's connected to 2 things. That's why there's a 2. The 2 things it's connected to are Cl that's bonded to 3 O's. Cl bonded to 3 O's. So you will see 1 Ca ClO3 2. Like you can see the structure and the formula come together through this activity. All right, then I put my arrow. Then, once again, I'm going to draw one thing. That one thing is calcium, but the calcium is connected to 2 things. It's connected to a chlorine on each side. And then, last but not least, I'm going to draw 3 things. And those 3 things are 2 O's that are stuck together. And then I would color. So I know this seems like busy work, but it really helps a lot of students finally click and understand what this chemical reaction process is. Are you all right, Blake? Let me restate that. You found another way to annoy me? It's all right. I'll take any annoying that you guys can give me. It's better than listening to my kids fight about Minecraft all day. So I love my children to death, but 3/4 of them, I was ready to 3/4. I was right now, yes. It might be Derek, but I won't name names, but it's him. What? Yeah.
Hey, you should invite me over. I'll drop your kids.
Derek is a kid in their grade. My child.
Wait.
He's in a picture right there next to my wife. Okay. We probably are like already out, huh? Okay, you can leave your colored pencils on your desk, and we'll finish this tomorrow. All right, Curtis, I'm gonna bounce.
Hi, Curtis. Hi, Curtis.
Alrighty, you have a good day.
All right, you too.